So in this thing, we're going to talk about the temperature homogenization problem. So if some of you might be familiar with this topic. If you're not, what I would say is, if you were listening earlier on, we were talking about this urban heat island, that you have these temperature records that have that are gradually experiencing urban warming as they're experiencing. But it's not just the urbanization, urban warming. That is a big problem. But there's also other problems. So these are stations. Actually, these are photos I've taken of three different stations that I just. This is Clonmacnoise and Automatic in Ireland. Valencia Observatory. Went down with Michael. It was a very rainy day. It was a miserable day, but it was nice. We met. We were talking to the observers there. It was had a nice tour around it. This is in Tromsø in Norway. And this is just to show you the Tromsø weather station. That's a road. It's just right beside the road. You have traffic going up and down here. It's like you can you this is not like a good clean site. This one is quite a good one. But a lot of these have buildings in it. And so if you have a change in the instrumentation or the observation practices, or you have buildings coming up around, or physically after 20 years, they say, look, let's move the weather station to another place. And this is, by the way, a Stevenson screen, and the thermometer is kept in there.
But
Uh,
even there is a problem with the Stevenson screens in that in order to accommodate new equipment and so on, they actually change the sizes of the Stevenson screens. And the bigger ones have a bigger heat capacity, so they don't show the same temperature ranges as the smaller Stevenson screens. Yes.
Willie, did you want to add
The
something?
famous Anthony Watt, our friend, actually studying the paint property.
Yeah.
Yes.
I mean, it is a complicated thing, and this is why it's a serious issue. And I don't know how many of you catch when in the first part, the second part, where Ronan says that even the rural station, the record that we use, we actually are careful enough to actually go over the temperature record where we have the information of how the history of the collection of data that we actually try to correct for any of this because even rural stations have problems, and that's the key statement here. That
I
we have to be very careful about all these so-called non-climatic biases.
Okay, there was some audio issues there, but I hope people caught the thing. I think it's fixed now. So, just to show you how we would like to do it, and so that's when we went down and visited. Michael and I went down and visited the station, and they told us, look, that this is up until from 1867 to 1892. It was on Valencia Island, which is off to the shore there, and I later went and visited.
Just to mention, the reason that it was there was that this when they laid the first transatlantic cable, it came ashore at Valencia there.
Yeah,
And so that's why they had the weather station there, and it was well maintained because of its association with. And also, when they started the first transatlantic flights, they landed there as well. So for a long time, a lot of funding was put in for to maintain this particular station, and it has been maintained to a very high scientific standard because of its commercial significance. And
yeah,
also, it had a lot of significance in World War II in trying to predict when to stage the landings in Dunkirk and that.
yeah. Now, so they had, and so this was, as Michael was saying, it was like one of the flagship. Initially, it was in the British Empire. It was one of the flagship meteorological stations in a rural, isolated area. Now, as some of you may know, anyone familiar with Irish history, in 1937 was the founding of the Irish Republic. We can have another talk about the history of that another day. But Michael has like and mine because I'm his son. We have one of our cousins was involved in the 1960s. It was James Conley.
Look,
Don't
that's
count me out. I'm the adopted son. So all right, I'm
Yeah,
one of
yeah. So
Connolly's.
anyway, we can talk about that another. But the point is, there was a change of administration. Went from being British to being Irish, but the staff and observations remained the same. But there was a station move in 2001, and they changed to the automated in 2012. But the Valencia Observatory, they provided us with the parallel measurements for both of those, and so
so
we
in
were
other
able
words,
to.
what they were doing there was when they made the station move, they continued to take the temperature records at the old station for 2 years. So you could compare the difference between the two stations.
Yeah, and what it turned out when you compare them, it actually meant that the new location was zero point 0.3 degrees Celsius colder. So the raw record, we would argue, you need to actually add a cooling adjustment or a warming adjustment rather. So
The reason for the cooling is because it was raised up and was at a higher level, but also it was further in from the sea and
yeah,
the mitigating effects.
and then we checked that the change to the automated weather station, the difference in the parallel measurements was less than 0.1 degrees Celsius with so no adjustments necessary. That's the approach that we took, actually using what are called station history metadata, or sometimes station metadata, documenting changes in the events that the observers were kept. But the most of the groups, including NASA and including NOAA, they don't bother with that. All of the groups, actually, all of the other groups, perhaps some of the national observers use it, for looking at regional ones, but for the global temperature reconstructions, they don't bother with using this method. Instead, what they use is mostly they use this automated temperature homogenization program. And so the main one used by NOAA and indirectly used by NASA, because they use NOAA's homogenized data. The JMA, the Japanese Meteorological Administration, the Chinese group, they do their own similar adjustments, and then the climate research unit uses similar ones. So what they
Ronald,
use is this
just a
Mene and
little bit.
Williams 2009 paper. It's called the pairwise
Yeah,
homogenization algorithm. Michael, do you want to just
yeah.
add?
I just want to clarify here. The whole point that we're looking at is when you move a station, it will have an effect on the temperature and on the readings in the new location. And what we were saying is that if we looked at when this was done in Valencia, that you could, because they kept station records and looking at the station records, we were able to establish what the change was. But NASA don't look that much at the station records. Instead, they rely on using computer generated algorithms for to try and eliminate station moves from the records. So
Yeah,
that
just to clarify that NASA use NOAA's homogenized data set as their input. So NASA don't apply these adjustments. NOAA apply these adjustments. NASA have a different adjustment. We can talk about that in another day, which is also flawed. But the NOAA's adjustment is the pairwise homogenization adjustment. And so just to show in our 2015 paper, we showed this, you saw that, we apply an additional add warming. And to say, you'll get some people say, why not just use the raw records, the unadjusted? And there is an argument to that. But like, if you know that there has been a change, or like urbanization, or when you move the station, it actually cooled or warmed the thing. You should correct for that if you know about that. So but how does Noah's adjustment doing? Well, this was a big shock for us because we downloaded it in 2011, and these were the adjustments. And the red dashed vertical red lines were the dates when there should have been possibly an adjustment. Those are the documented events. But none of the adjustments were applied in any of the period. But
I
then for the 2015 paper, we downloaded the data set a couple of times. And what we found is the adjustments that were being applied to Valencia, instead of being one, not only were they not lining up with the documented events, but they were changing every month. Every time we downloaded it, the adjustments to 1900 were different. So the temperature for 1900 and Valencia Observatory, that changes in NOAA depending on whether you download the data set on a Tuesday or on a Wednesday. It'll NOAA will tell you it was a different temperature. Yeah, so
What what we find interesting here, just leading on to the next bit, was uh, Ronan and I were at a meeting in which we were talking to Peter O'Neill, and we
yeah,
were pointing this out to him, and he was saying, "Well, he said I have been downloading their data every so
Every
often, so we had only done it a few times, and we were saying this was ludicrous. But it subsequently transpires that he was downloading them, and at one stage, NASA rang him up and said they hadn't got a record of their downloads and could he give them theirs. So
yeah. And
Peter O'Neill.
to clarify, because Michael merges NASA and NOAA as synonymous, and they actually so Peter has also been downloading NASA's temperature records as well and their temperature data set. And so yeah, but he has also been in communication with NOAA. So and pointing out problems with them, and they'll correct that as well. NASA and NOAA are both uh, separate U.S. governmental organizations, but there's a big interplay between them. Willie, did you want to add something
Yeah,
there?
I want to add one remark. I mean, obviously, that this is something that don't come along every single day. This is one of those great blessing when you pursue truth and science. Peter O'Neill is among is in my book. He's a hero for this area of climate science just because of what he did. He cared enough that he downloaded this different version, and now we are the only unique depository that have this of all the different version. Not because they want to poke hole this and that. It's just trying to document the history. What is how much the thing costs for them to keep this, and they delete all of this. This is why
Yeah,
it's embarrassing for NASA GISS to actually ask Peter for a version of some version that they deleted. They are so arrogant in terms of their approach to science that it's a bit, like hiding the decline. You may have heard of that too. That's another area of problem in hockey stick. But this is a very beautiful piece of paper study. I am very, very proud to be even able to come close and be really studying this issue. By the way, it cannot be done if Peter didn't keep this record. I just want to
yeah,
say how much I think so important for all of us to put our best foot out, to keep science and objectivity in mind, to not keep constantly trying to say that I want to win this, win that, whatever.
yeah.
There is nothing to win in this.
By
We
the
need
way,
to keep
I
pursuing truth.
think so it's something we should bring up here. When we did that study, the download that we happened shortly afterwards to go to New York, and we rang up NASA GISS, and we were talking to Gavin Smith,
Yeah,
and we said we had problems. So we arranged to meet Rato, wasn't it?
Rachel
In,
O'Grady,
I told
Dr.
you,
O'Grady.
yeah, in the restaurant underneath their offices.
Yeah,
And we had a whole afternoon discussing
the
the
Seinfeld
different,
restaurant. Yeah.
and their attitude was they hadn't thought of that. So
yeah, yeah. So
I was, just to let you know, as scientists, we had to cover the problem, and we went directly to them and had discussions with them. So it's not like as if we were keeping it in the dark. And this was before we even started.
But they are not serious. They're just not doing anything to change it.
Okay, so I had actually been thinking we could have mentioned about these things, but I said no.
I
Let's
think let's
focus
stick
on
to the site.
the two Katata et al. And the O'Neill et al. But since you mentioned it, I will just put it in. So yeah, what Michael is referring to there is so in 2014, we published a number of papers. Michael and I, and we set up the Open Peer Review Journal. If you were listening to the last week's podcast, we talked about the weather balloon papers. But we also published papers looking at the temperature records. In one of them, we looked at uh, NASA GISS's GISTEMP adjustment. So they have an adjustment that they call the for urbanization bias specifically for that. We went and we did a deep dive into it. We found identified, I think, like seven critical flaws in their analysis, and in it, which showed it was not removing urbanization bias. It was actually causing more harm. It was selectively doing it. Only in like 10% of the urban cases was it actually removing a long-term warming, and most of them was actually adding in warming. So there was a lot of problems. We showed why it was causing the problems, the errors they had made, what the problems, and we published that. It's available if you go to oprj.net. um, Urbanization Bias Paper 2, looking at the GISTEMP records. But Michael and I, this was when we first started collaborating with Willie, and we went to visit him in Massachusetts in 2015, the winter of 2015. And then we said, let's visit some of the other groups. So we said we'd visit um, the NASA Goddard Institute, and Dr. Gavin Schmidt kindly, he was too busy at the time, but he kindly arranged for us to have a meeting with Dr. Ruedi, who he said he's the expert on GISTEM. We went through it. Melda, my mother, was also there as well. She also was joined in, and the three of us we discussed the things. We went through every single one of the flaws that we'd identified in the NASA GIS adjustments. When we pointed it out to Rato, he said they hadn't considered it, and we asked him, "Well, do you see how it could be a major problem?" And they said, "Yeah, it could be." I said, "Well, will you check?" And he said, "Yeah." And then we asked him at the end. We said, if we made any mistake or if you say any problem where you thinking that it's already been accounted for, will you let us know?" And he agreed to say that he would let us know if there was anything, or if NASA GIS decided to update their algorithm to correct for the serious flaws that we had identified. That was 2015, was February 2015. And we
Now,
have,
10 years later.
yeah, 10 years later, they
I
still
think,
have not
Ronan, let's
corrected.
focus on this paper. Come on.
Yeah,
Don't
so
do that.
okay, so to get on to that, so that's the NASA Goddard Institute's urbanization adjustments. That's a separate one that they now, since 2012, they added on top of NOAA's homogenization. And that introduces a problem with the urban blending. Okay, so uh, as we were saying, Peter had been downloading the NOAA's GHCN files every day for for years. So we had thousands of different copies of the GHCN, and we said, well, let's compare. We saw we did that for Valencia Observatory. We had the station history metadata for that, and we said, well, can we get the station history metadata for other stations and in Europe, because there's a lot of works. And so we reached out, and this is a collaboration involving 17. There were 17 of us from 12 European countries, everywhere from Austria to Ukraine. And we reached out to these different groups that contributed, and most of them were contributing the station history metadata. And we need to stress that the co-authors don't necessarily agree with our views on climate change, or they may take the IPCC's assessment. It's just this was a collaboration on this specific project, and
So
they all agreed with the analysis. They all contributed, and they all said, yeah. They said, yeah, what we have found in this paper is valid, and it's shocking, and they were all shocked, and we were shocked as well. You want to
Actually,
add
I
something
saw the
there
result.
before we go to the next slide, Michael? Or
no, it's
Next
okay.
slide, please.
okay, so, yeah, so to explain what it is that we're talking about, if you go to NOAA's website, if you Google Global Historical Climatology Network monthly data set, or you could do GHCN monthly or something, or NOAA, you get to this website and you can download it and you can see. I went to this and you just click on the download. You can see the date at which was downloaded is that was on St. Patrick's Day. Okay, we did that the day
Right, 17.
2 days ago. Um, Peter has been doing that um, from basically a few times. Basically, from early 2014, he switched to downloading it every day, and some days it's repeated, and then they transitioned from version 3 to version 4, and he'd been downloading the beta, he downloading it. So we have 1877 versions of version 3, 1812 versions of version 4, and yeah.
Just to stress here, what we're saying is that every day they readjust the data on all of the station records. So if you look and you wanted to do an analysis today, and then next week you come along and you want to redo the analysis, the data they have is totally different. And in most of the cases, as we'll show, they are not at all related to the adjustments they made a week before. So which set of data is correct?
Yeah, and so Peter had reached out to Noah when he first discovered this, and he said, do you know that this is happening? That, like, because you download a homogenized version of Valencia Observatory, or I think Peter was looking at a French station that he was familiar with, and he said, wait, it's changed. It's a different. The temperatures in 1906 will change March 1906. They're different depending on the day you do it. And he said, "Are you know about this? Why is it doing that?" And he said, "Yeah, that's they know it. It's called a day-to-day flutter."
Flutter.
Okay, so
Okay.
how much flutter and how well do the adjustments apply? So let's just look at one of the stations we analysed, Cheb in the Czech Republic. This is an urban station, so you can see the raw record shows a long-term warming. Um, and but we have 1,770 versions of it over this 6 year period. It's a different records, and what we found is the adjustments. Um, there was 269 completely different sets of adjustments that were applied to that homogenization adjustments were applied to it. And so to say that our Czech colleagues, they said there was an instrument change in January 1955, there was a station move in January 1961, and then in January 2001 they moved the station and shifted it to an automated weather station. Now, I've highlighted those with those blue vertical lines, if you can see them. And we will say that this is how often the homogenization algorithm identified it. And it correctly identified that there was an instrument change or something happened in January 1955. And they got that 100% of the time. They didn't identify any change for the station move, but for the January 2001, 60% of the time the algorithm said, yes, something happened there. But 40% of the time it didn't identify it. So it's inconsistent. But here's the big thing. You have all of these adjustments. So only 6% of the time, this is the most common set of adjustments, was this one. And this was a different set. So this is a different set of adjustments that was applied, and that was applied 1.5% of the time. You see, it showed added warming, whereas this would added cooling for there. They showed different adjustments and show that these can have implications for most of the time for Cheb, there is, because this is an urban record, most of the time it has a net cooling. The homogenization has a net cooling of between zero point 0.5 and zero point 0.8 degrees Celsius per century. Um, that occurred nearly 60% of the time. Is in those values, different values. But like a quarter of the time, it doesn't reduce it by that much, and 15% of the time it reduced it by more. And you can see this is the net adjustment applied if you download it on that day, minus zero point 0.7 degrees per century. A few weeks later, it only added, it cooled it by minus zero point 0.3. Few weeks later, it cooled it by nearly 1 degree. And you can see this is the day to day flutter. It's like changing it by more, like between 1 degree to zero point 0.2 degrees Celsius per centigrade. That's as much as the global warming that we're talking about.
Yeah, exactly.
Yeah, that we're doing it. And you can see, and then here's the thing, 7% of the adjustments only occurred, they were one off. They applied an adjustment never to be replicated again in the 1700s. And then 4% only occurred twice, and only 34%, about one third, was it reproduced? Was it replicable? And even then, we saw only 6% at the time. Yeah.
I think enough of details. I think the summary is called for. I mean,
Yeah.
just think
Let's
about
go
it.
to the summary.
2022, we produced this, okay? And
Yeah.
2022, after how many years that those data were created? I mean, in the
Yeah.
90s, I believe, by Russ Vogt and a bunch of those people.
Yeah. Yeah.
And
So,
they don't bother. They just want to use this homogenization. I mean, that's really terrible. And then let's summarize, Ronan. You do
yeah,
it.
so just to summarize this paper, what we did is these are the red circles, if you're looking on the map, are the locations where we could get detailed station history metadata. And so we decided we just analyzed those 800. It's a large sample from 24 European countries. So 800, more than 800 weather stations. And what we did is we said, first of all, how often does NOAA's automated homogenization? So they do this automated. They don't have any station history metadata. They're just basing it on statistical properties, comparing each station to station neighbors. And they just say, oh, one goes up, one goes down. There was probably a station, something happened in January 1972. Let's apply an adjustment. We'll talk about that more in the next part. But did they coincide with documented events? Oh, less than 20% of the time does it occur. Now, some of those may be genuine, undocumented ones, but the bottom line is we'd be expecting, all of our co-authors were saying they were expecting most of the adjustments to actually coincide. And it's like less than 20%. But again, only 17% of the adjustments actually were reproducible. They kept on occurring.
83% is the one that you want to say.
Yeah,
83% or not. So it's crazy. It's not consistent.
83% where you download it one day, you'll never see it
Yet
again.
again. Yeah.
And so this, we summarize the paper with this quote from the economist Schumacher, who pointed out this nice analogy. He said, a man who uses an imaginary map, thinking that it is a true one, is likely to be worse off than someone with no map at all. So what we're saying there is, if 83% of the adjustments are different, how do you know which one is correct? How do you know if the version you
Or
download on
regular.
Tuesday is more reliable than the one on Wednesday or Friday? Yeah.
Yeah,
I
well,
just want to add another bottom line. Don't use homogenized data. That's it. When you hear that word, the milk you can drink, please. Milk you need to because you
It's
want
a
to get
real, it's a
sugar.
real imaginary map.
Okay, so that was looking at Noah's
Okay, Katata
homogenization.
please.
No, so this is the problem. So you saw the inconsistency, the lack of relevance to actual documented events. So there is an implausible thing. But this other paper we published, Katata et al. 2023, and then it was three of us, Peter, myself, and Genki, but Willie and Michael also were involved. They helped. They gave us a good bit of help. But this was like the three of us focused on this with a lot of assistance from Michael and Willie. And then, but what we did here is the to summarize it, what they're doing is they're using the each temperature record. They look at it and they look for nearby stations. This is a computer program. The pairwise homogenization thing doesn't look at any documented events except for the USHCM. That's a site, but they discontinued that. Um, they look for nearby stations, and then they say, this is. They look and they say, oh, January is hotter than average, February warmer, cooler than average, and they look and they compare the ups and downs of Valencia Observatory with a Dublin airport, which Burr, with so they'll take one station and they'll look at 100 stations nearby, and they will say, "Oh, most of the stations show that there must have been a jump." Okay, and so that's identify what's called a breakpoint. And then the next thing is they say, well, let's apply an adjustment for a non-climatic bias. And they don't know what it is, but they say relative to the other stations that there was a non-climatic bias. So this is the problem. What we'll show, I will explain why. So that what they find is after temperature homogenization, all of the stations are homogeneous. They show the similar trends. And so the homogenization gets rid of these big non-climatic biases, step changes. They don't correct for urbanization bias, by the way, because that's a long-term one. They're just looking at abrupt changes from one month to the next relative to the neighboring stations. And what they did is they showed, so what we showed is, so we're pointing out in this paper, we show when they mix, they homogenize it. What they've done is it's like putting strawberries and bananas into a blender, and you blend them. And what you end up with at the end, you don't end up with pure strawberries or pure bananas. You end up with a smoothie that's a mix of all of the fruit in that. So it can be tasty. I quite like some smoothies now and then. It is a technical problem, but is it real? How significant is? Well, in Katata now we showed this. It's real and it's serious, and we do several different examples. So this one here in Japan, these stations here, we looked at all of the stations, and we're looking at the period with the maximum overlap, which was 1955 to 1990, that all of the temperature records had data for that period. And what we do is we've ranked them from most rural to most urban. So 0 is the most rural station of all, and 1 is the most urban for the island of Japan. And what we do is, if you look at the blue line, these are the linear trends from 1955 to 1990 for each station. And you can see there's differences up and down and up and down. But if you can draw a straight line through, and you can see that the most rural actually had a cooling trend for that period, and the most urban have a strong warming trend. So the difference is this one had a cooling of a minus 0.89 degrees Celsius per century versus I think it's plus zero point 0.8 degrees per century for that period. That After homogenization, there's almost no difference with urbanization. They all show basically the same trend. So what you can see that line, the orange crosses, they are homogenized versions, and you can see that there's no real trend now. You might say, oh, we got rid of the urbanization. No, look what happened. The rural stations had warming added. The most urban had warming removed. And they all are converging towards this midpoint, which is the average of the whole network. So essentially, in the homogenized temperatures, all of the homogenized Japanese records show the same warming as the moderately urbanized stations,
In
which
other
contain
words, the
urban warming.
rural temperature records and the urban temperature records are all blended to give you an average value.
And
Of
that average is the average of urban stations.
yes,
And just to show, was it Japan is highly urbanized? So
To
we,
USA. Yeah.
we also look for the rural, or for the USA. Now, the USA, while a lot of people think of the urban areas a lot of non-Americans in particular, think of what you see on Hollywood. Most films are in LA, New York City, Chicago. So a lot of Hollywood, you see urban areas, but actually most of the USA is quite rural. And so we have a lot of stations going back to 1895 that are rural. So we are very able to do a good analysis. Now, one adjustment. So now we're looking at 1895 to 2022. And again, the trend you can see, the more urbanized they are, the more warming you've observed. And you get that almost no long term warming in the rural records, 0.026 degrees per Celsius per
Per
century.
century.
Um, in the most rural, but in the most urban, 1.2 degrees Celsius per century. So that's a big difference. After homogenization, they all show an average of
1.2.
1.2 degrees Celsius per century. Doesn't matter whether it's rural or urban. And what you can see is the warming is added to the rural. And yeah,
I mean, this completely explain why sometimes you see the graph where they demonstrate to you that look, we have homogenized urban look like this, and then homogenized rural they look the same.
yeah.
Well, you just
Even
did it. Congratulations.
go
I
back,
mean,
go
I
back to
hope you
that.
guys get this point.
Go back to that smoothie. They blended it. They've
Yeah, yeah.
blended
Everybody
urban
is
and
the same.
rural. So I guess in terms of smoothies, this is a urban rural smoothie, and as opposed to a strawberry banana
Banana.
smoothie.
Yeah. Okay,
So
conclusion.
now,
so
now,
just to summarize towards the end,
yeah, yeah,
uh, what we're looking at here is you see all of this stuff and it's all coming out, and you would say, look, this is all serious problems with what they're doing. What is the World Meteorological Organization saying about this? Well, they've just announced yesterday that we have the warmest year on record,
yeah,
and they did that
2024.
by just totally ignoring all of the problems and just looking at the rural urban mix of stations.
yeah.
So if they were a true scientific organization, they would look at these problems and try to account for them.